many things in this. Yes. Welcome to database training session. In our last session, we worked with database table alteration. Similarly, we saw how to insert data in the explicit as well as in the implicit mode. Okay, we saw how alter command is working. At the same time, how to use how actually you can insert data into a table in the implicit mode as well as in the explicit mode. Today we are going to work with operators which are available in the SQL Server. We are trying to explore various operators available with SQL Server. Okay, so let me first of all open the database on which we are going to work. So here it's going to open for us a query editor window. So this is going to be query analyzer window. So in this query analyzer window, we type give use command followed by open the database name. Here it is. We started with the first DB. The other day we have done with the first DB. Let us see what tables we created in this. There are two tables, one is TBL login, other one is TBL user. So open this database. It is first DB. In our last session, we saw how to create relationship between the two tables with primary key and foreign key columns. We saw even that. Now let us discuss about the operators. Today we are going to explore the operators because these are required very much. Now let us look into TSQL operators. We look into TSQL operators. See, just like any programming language, even TSQL is also a language, but it's not a full-fledged language like C or C++ or C# or Java. Only we use it for writing procedures, writing triggers, or writing actually anonymous code blocks. We use it. So interact with the database, we require the TSQL. Okay, so far we have seen few SQL commands. We know that there are 5 different types of SQL commands: DDL commands, DML commands, DCL commands, TCL commands, and DQL commands. We have explored so far DDL, in which we saw how to define a table, how to alter a table, how to drop table. In the same way, we have seen few DML commands. That's exactly insertion, updation, and deletion. Also we have seen from the database table. Today we are going to look into various TSQL operators because these are often needed in select statement. Similarly, sometimes in updation also we can use. Okay, the TSQL operators, first of all, we have arithmetic operators. Okay, we have here arithmetic operators: plus, then minus, then multiplication, then division, and remainder. You can find even remainder using this percent symbol. Okay, here they follow BODMAS rules, and sometimes we use even bracket, set of brackets we use to make a group. To group the operands we can use, or to group the expressions we can use them. So using these operators we can actually form expressions. We can form here arithmetic expressions. Okay, even plus sometimes can be used with date time. Okay, you can even use to concatenate strings sometimes, but here in the context of arithmetic operations we are trying to explore it. Plus, minus, multiplication, division and percent. So plus is for addition, minus is for subtraction, then star is for here multiplication, and slash is for division, and percent is for finding out remainder. So for that purpose we use it. So using these operators you can perform arithmetic operators, and these you can use for grouping. Okay, for grouping purpose we can use. Fine. These have very highest precedence. Normally they follow Bodmer's rules. So first of all, these brackets they have highest precedence, followed by division, multiplication, addition and subtraction. Like that they have the precedence. Suppose if I write something like this, 2 multiplied with 3, 2 multiplied with 3 plus 5, if I put here, it's going to multiply first of all 2 into 3, then after that it can add. Similarly, if you write here 2 plus 3 multiplied with 5, when you say first of all 3 is going to be multiplied with 5, result is added to 2. So star is having higher precedence, or multiplication symbol is having higher precedence over addition or subtraction. Fine. Now here plus is for addition, minus is for subtraction, star is for multiplication, slash is for division and percent is for finding out remainder. Okay, so plus we use normally with the two operands, so it is going to be a binary operator. Minus can be unary or it can be binary. You can use only with one operand, or you can use with minus, with more than one operand, minus. Star requires actually two operands. Even slash requires two operands, percent also requires their two operands. So therefore they are going to be here this plus, minus, multiplication, division and percent we can use for performing various arithmetic operators. So except minus you can use as unary or binary, whereas other things normally they are binary operators. Okay, these brackets we use for grouping. When you want to group things you can use the brackets. Now for example, you have to do like this. You need to first of all say add 3 plus 5, then after that you have to multiply the result. Therefore in such cases you can put this way, 2 multiplied with 3 plus 5. Now what happens here, 3 and 5 are added, then multiplied with 2. But if you don't put any brackets like this, and here if you go with 2 multiplied with 3 plus 5, that gives us 30 result. Even this one, how much it gives? It gives only 16 here if you group like this. So how you want to evaluate expression? First of all 3 must be added with 5, then followed by you need to multiply with 2. So in such cases you put in the brackets, you get the correct result. If you write expression like this, first of all 2 is multiplied with 5, okay, 2 is multiplied with 3, then to that we are going to add 5. So here result is going to be 11, but here result is how much for us? It is going to be 16. So you get different results. Okay. Therefore here you need to use brackets for grouping purpose. Next, you need to follow certain rules whenever you deal with the arithmetic operations. When both the operands are integers, result is going to be always integer. Whenever you write any expressions, take care, if you require the result in the floating point manner, definitely one of the operands must be floating point. Otherwise, if both of them are integers, result is going to be integer. For example, take, you have 3, when you divide with 2, you have a 6 here, when you divide with 2, result is 3, this is fine. But suppose you want to divide like 22 by 3, so in such cases you get the result as here 7. You get only 7.0 something you get. You are not going to get actually 7 point something there, you cannot get there. Okay, so this is what exactly, this is going to be I mean, whenever you perform arithmetic operation, here 22 is an integer, 3 is also integer, therefore result is going to be, you have only integral part. Like this, you get the result. Okay, so it can't be, you cannot get actually 7 point something there. So here, whenever you divide 22 with 3, 3 sevens are 21, then followed by 7.666, something like that you need to get, I think. Okay, let us see what exactly we get. 7.6 followed by probably 22 by 7. 3 sevens are 21. Okay, followed by, you get 1 as remainder, you add 0. Then 3 3s are 9, you get 1 0, 3 3s are 9, like that you are going to get. So 7.63333, like that you are going to get. I think like that, yeah. So this is going to be 7.3333, something like that you are going to get whenever you divide the 22 with 3. Okay, so normally you should get that value. Since both of them are integers, you get a value like 7.0. Let me demonstrate that. You need to follow this rule. When both operands are integers, result is going to be integer. If one of the operands is floating point number, result will be floating point number. Like that, you get the result. You are going to get result in that manner. Now we come to this and try to demonstrate to you. Here I want to find out result of, I want to use sum here. Select, I write like this, 2 plus 3. 2 plus 3 I use, execute. This result is going to be 5. It displays like this. No column name. You can put something like addition. So in such cases, the column name is going to be addition for us. Like this we use. Addition is 6 here. In the same manner, write, select 2 minus 4. Put like this. Then again write here subtraction. Okay. Then go here and execute. You get this time subtraction. 2 minus 4 is going to be minus 2. Now do like this. Select here 2 multiplied with 4. Result is going to be, this is product I put. Result is going to be 8. Execute this, you get result as 8. Now this time divide, select 2 divided with 4. Then this is quotient. Like this we write. Then go home, then execute, you get the result as 0. The quotient is going to be 0 here. Okay, 0 point something you need to get. 0 point how much we have to get here? 0.5 you have to get. 2 by 4. 2 by 4 is nothing but 1 by 5. Sorry, 1 by 2. 1 by 2 is 0.5. But we are getting result as here 0. Since both the things are integers. So now here what you can do, one of the things you make as floating point number. You get correct result. Select 2.0 divided by here 4. Therefore, you get this time quotient as, this is going to be 0.5, you get this time result. So just execute. You get here 0.500, like this you are going to get the data. So what is happening here, when you take 2.0 and when you divide with 4, it gives you here 0.5. Because one of the operands is here floating point data, therefore you get correct result there. Select 2.0 divided by 4, when you say, that's going to give you 0.5. So like this here, you are getting the result in the floating point manner. If one of the operands is floating point, then you get that result. If both of them are integers, you get actually integer data only. Like this normally these are going to work. So these are arithmetic operators. Similarly, I want to demonstrate to you this operation. Okay, so select followed by here, I say here 10, this is 7, here it is remainder, I put like this. It gives you 3 as a remainder. 7 ones or 7, remainder is 3. You get this as here 3. So like this, these are going to be arithmetic operations. 2 plus 4, 2 minus 4, 2 multiplied with 4, 2 by 4, like this you get. So these are nothing but here arithmetic operators. Okay, so these are arithmetic operators. Either you can use select statement or you can use print statement. Normally we use select for retrieving data from the tables. along with queries you must use. But here we are simply using to select data. If you don't want to use select, you can use print also. You can use print followed by 2 plus 4. This works only in the SQL Server SSMS. Outside it does not work. It's giving you 6. It's just giving you result. Like this print statement also you can use to test. Different things we can use here. Print statement. Okay, whenever you work with SSMS, you can use it. But normally in the queries you should not use such things, or in the procedures you should not use such things. Okay, so here when I write 2 plus 4, it's giving me result as 8. This time it's not coming in the tabular format, but when you take select statement, in such cases you get in the tabular format. Just execute, you get 6 in a tabular format. Row number 1, column is addition. Like this, it's going to show in the table. But when you go with print statement here, it's going to be shown in the simple, like simple text, it's going to be shown. No tabular format here. Like this, the result is shown. Okay, now come to other operators. These are what exactly? Arithmetic operators. We have next operators are relational operators. We have here relational operators. The relational operators are greater than, less than, then greater than or equal to, less than or equal to, like this you can use. These can form a relation between the two sides of the equation. Okay, between the two sides of the equation they can form a relation. So normally these are inequations only. To form inequations we try to establish relation both the sides. Sometimes you can use equality operator, and sometimes even you can use not equal operator. These also you can use. You are trying to establish a relation between the two sides of the expression. When you take arithmetic expression, you have terms. In the left side you can have a term, in the right side also you can have a term. So you can establish the relation between the two terms. Okay, so these are called as relational operators. Suppose you write here, say 5 greater than 7. This can be returning you a false value because 5 cannot be greater than 7. Similarly, if you put 5 less than 7, this can give us a true value because 5 is less than 7. Similarly, you may write like this, 5 less than or equal to 7. If you put, this also returns a true value. But when you try to put 5 greater than or equal to 7, that can be returning a false value. So when you say 5 greater than 7, this is going to be true only. Okay, but when you say 5 less than 7, this is false. Similarly, if you do like this, 5 less than or equal to 7, this can be a true value. So it is going to evaluate in the given expression the two sides. Okay, so these normally form inequations, or sometimes equations also you can get with that. Okay, so these operators also we use very much in our code. We are going to use these very much in our code. Now come to this here, try to see result. Print 5 greater than 7. Now come to this home, then here execute. Syntax is incorrect here. You cannot just write like this. Print 5 greater than 7, it cannot give anything for us. So therefore, here try to do with the select. Select 5 greater than 7. Even this also gives wrong result. Like arithmetic operators you cannot use. These you have to use in some expressions. In some program you need to use. Small code blocks you can use. In that small code blocks, you can put these. So they are going to be arithmetic relational operators. Similarly, we have logical operators. Okay, so when it is logical operators, they are going to be logical AND, we call it as. Then OR operator, it is logical OR. And one more is here, NOT operator, this is called as logical NOT. Okay, even this exclamation also you can use. AND operator, OR operator, NOT, even this exclamation also sometimes you can use. Okay, that can be logical NOT operator. AND operator is going to combine the individual expressions into newly formed expression, new expression. So newly formed expression is going to be returning true value when all the combining expressions are true. If any one of them is false, the result is going to be false. OR is going to combine all the individual expressions into a new expression that returns a true value if any one of the combining expression is true, because OR we are using. So, but when all are false, it's going to be returning a false value. In the case of NOT, if it is true, that input expression, if it is returning true, that gives false. If that is false, it gives true. Like this, we use the logical operators. So logical operators are going to be here AND operator, OR operator, and NOT operator. Okay, we have here AND operator, OR operator, and NOT operator. Like that, we use these logical operators. And along with these logical operators, we use here sometimes bitwise operators. They can work at the bit level. So we have here bitwise AND, bitwise OR, bitwise exclusive OR operator. This is bitwise AND operator. We call this as bitwise AND operator. Similarly, we have here, this is bitwise OR operator. Bitwise OR operator. And last one is bitwise exclusive OR operator. OR operator we have. So first of all, let us look into bitwise AND operator. It is going to be working with the bits of the two given numbers. For example, you take A equal to 96 and B equal to here 64. Now if I try to perform A and B, for example, I perform like this A and B. Here I get the result as 64. Similarly, if I take A or B, if I go with the A or B, the result is going to be here A or B. If I take, it's going to be 96. It's going to be 96. But with A and B you get 64. With A or B it's going to be 96. Similarly, if you go with A exclusive B, you get the value as 32. Like this, these are going to be getting evaluated. So what we do there, A and B equal to 64, A or B equal to 96, cap B. So this is here exclusive OR operator. So in such cases, we get the value as 32. So why it is so? See, now take A equal to what we write, 64, 96 we write. 96 when you convert into binary format, that is going to be in the 128 position, it's 0. Okay, in the 128 position, that's going to be 0 for us. Fine. Now followed by in the 64th position 1, in the 32th position 1, then here in the 16th position, in the 32th position, that's going to be 0. Then in the 16th position 0, in the 8th position 0, in the 4th position 0, then in the 2th position it's going to be 0. Okay, so this is exactly what 128 position, then this is 64th position, then 32th position, then this is 16th position, 8th position, 4th position, 2th position and 1st position. We know that binary numbers, as you move from right to left, they increase by 2 units, 2s, 4, 18, 16, 8, 16, 32, 64, 128, 256, 512, 1024. Okay, so 2048. Like that, as you move from right to left, they increase by 2 every time. It is something similar to decimal numbers. In the decimal numbers, as you move from right to left, you increase by 10 units, tens, 100, 1000, 10,000, like that they move. But most of the time we depend on the base 10 system. When you go into base 2 system, the positions they change. The rightmost side is going to be in units. To the left of that, it's going to be 2s. To the left of 2s, it's going to be 4. to the left of the 4 it's going to be 8. Like this they increase. Now take b also. B equal to what value you get here? It is b is 64. So 64 is going to be in the 128 position 0, in the 64th position 1, in the say 32th position 0, in the 16th position 0, 8th position 0, 4th position 0, 2th position 0, units position 0. Like this you have here a and b values. When you convert to binary format you get that way. Now here we perform AND operation on this. We are going to perform an AND operation here. Okay, we perform here AND operation. The result is going to be, now for us here we get a result. This is nothing but a and b. We can put like this. This is equal to, now what happens in this? If you try to add here, 0 and 0 is going to be 0, 1 and 1 is 1, 1 and 0 is going to be what exactly? 0, because when you perform AND operation the given bits must be 0. In the 128 position here also 0, here also 0, 0 and 0 is going to be 0 only. But in the 64th position you have here 1, here also 1, therefore 1 and 1 is 1. But in the 32th position, in the first number it is 1, in the second number it is 0, therefore 0. So rest are also going to be zeros. So in the bitwise AND operator, in both the numbers at the given bit position, if they are 1, result is going to be 1 for the newly formed number for that bit position. Okay, so therefore here what is happening? In the number A, in the 128 position, this is 0. For B, in the 128 position 0. Therefore, newly formed number A and B is going to be in the 128 position 0 only. In the same manner, if you come to 64 position, in the A, in the 64 position it is 1. In the B, in the 64 position it is going to be 1. 1 and 1 is going to be 1 when you form here A and B. Okay. Similarly, here when you look at A, in the 32th position 1, in the B in the 32th position 0, therefore 1 and 0 is going to be 0. So in the rest of position what is happening here? 0, therefore we have 0. So therefore A and B is giving you here, the value is going to be for us 64 here. It's because in the units position 0, 1 into 0 is 0, plus 2 into 0 is 0, then 4 into 0 is 0, then similarly here 8 into 0 is 0, 16 into 0 is 0, 32 into 0 is 0, but 64 into 1 is going to be 64. So 64 plus 0 is 64, then 128 multiplied with 0 is 0, 0 plus 64 is 64. So like this we get here the value. Okay, we are going to get value that way. Here this is A and B operation, bitwise operation we are doing in that. Now next one is A or B we use. What happens with A or B? Let us see in that. Okay, come down here, then paste right here OR operation. This is going to be OR operation. Here I want to perform A or B operation. Go with this. Then here you have to have like this 0 and 0 0. 1 and 1 is going to be 1. 1 and 0 also must be 1 here. Like this we have. So 0 and 0 is going to be 0. 1 and 1 is 1. 1 and 0 is also 1. Any one of the inputs, if it is true, it is going to be therefore 1. Therefore 1 and 0 is going to be here 1 only for us. Rest are zeros, so therefore you have 0 only. So therefore the result is going to be for us here now 96. Because in the units position 0, in the 2's position 0, in the 4's position 0, in the 8's position 0, in the 16th position 0, but 32 position 1, 32 multiplied with 1 is 1. Okay, 32 multiplied with 1 is 32. Then similarly in the 64 position you have 1. So 64 multiplied with 1 is 64. 64 plus 32, 96 you get, followed by the 96 in the 128 position 0, that is. So therefore you get the result as here 96. When you perform A or B operation, that is going to be here for us 96. Like this we get the result. This is what exactly 96 you are getting. This is going to be the result for us here. Okay. Now next come to here, exclusive OR operator. We use now the other one, exclusive OR operator. Copy this and paste here. Then here put a cap symbol. We use a cap symbol. Then after the cap symbol, here let us try to perform A cap B or A exclusive OR B. In the exclusive OR, either in the first number in the given bit position it should be 1, or in the second number in the given bit position it should be 1. In both the places it is 1, it is going to be 0. In both the places if it is 0, it is going to be 0. So therefore here 0 and 0 is 0. Here 1 and 1 is going to be 0 for us. But here in the A, in the 32's position 1, in the B, in the 32 position 0 this is. So therefore this will be 1. 1 and 0 is 1. In the rest of the places zeros, therefore 0 you have, this is going to be 32 for us. Like this, these get actually evaluated. These are called as bitwise exclusive OR operator. Let us see this in the SQL query. In the TSQL, how this works, let us see. Now here, go with this print. Okay, print here 90, 96 and 64. What result we get? See in this. Just execute here, you get the result as 64. What I said there, 96 and 64 is going to be for us 64. Similarly, here we take print, here we print 96 followed by here 64. Result must be how much for us? This should be 96. We need to get this as 96. Result is going to be 96. Similarly, we do with the exclusive OR operator. We should get now in such cases result as 32 for us. We get here this time result as 32. So like this, these operators they are going to work. This is called as bitwise operators. 96 and 64, 96 and 64, 96 and 64. 96 and 64 is giving you there how much? 64. 96 or 64 is giving you 96. 96 exclusive or 64 when you say it's giving you 32. So like this, here you are getting different results when you use these bitwise operators. Okay, now let me demonstrate the logical AND operator as well as relational operators. So for this, I would like to use some small program. Okay, I am going to write here some anonymous code block. I am going to write here some anonymous code block. There I can declare few variables. Normally code blocks have a name. When you write a procedure, for procedure you give a name. When you write a function, for function you give a name. But here what I do, I don't write any, I am not going to save it permanently. Only time being I would like to execute. Therefore I write here some anonymous code block. A program I am going to write, that program is going to be getting executed immediately. So in that I can declare few variables. Then ultimately using those variables I try to manipulate data. I should get some information out of it. So I have a question like this. I have 3 subjects marks. I have actually 3 subjects marks. Subject 1, then subject 2 and other is subject 3. Based on the subjects marks I should get here total as well as result. I should get total and result. For that purpose I need to follow certain rules. In each and every subject, if the candidate is getting more greater than or equal to 40 marks, in such case the result is pass, otherwise result is fail. So therefore here I use relational operators as well as logical AND operator. With that I try to find out result. And to find out total, normal arithmetic operation I can use them. So condition is what here? In each and every subject, that is in subject 1, subject 2, subject 3, when I have marks which are greater than actually say 40, in such cases the result is going to be here, the result is going to be pass, otherwise result will be fail. Like that we try to do it. So result is going to be fail in such cases, that way we do. So let us try to write here now the piece of code. Let us try to write that piece of code here. I am going to write here some anonymous code block. Therefore I can put comment, a single line comment I put here. Following anonymous code block calculates result. Like this I want to make it. This is going to calculate some result. This anonymous code block is going to calculate some result. Okay, I am going to write some anonymous code block. With the help of that code block, I can calculate here result. Here first of all I need to declare variables. To declare variable, I must use declare keyword, then followed by I should declare here the variables. So declare, then here I should use this kind of mechanism at the rate s1 followed by int this equal to, okay, I declare like this. Then similarly I can declare one more variable, declare at the rate s2, this is also int, then right here declare, then at the rate s3, this one also int. Like this I declare here three variables. I have declared here three different variables. So these variables are used now to calculate result, okay, calculate total. At the same time I have here total, okay, even this is also integer. Then one more thing is declare at the rate result, this one char of 4, because possibilities are what, either we can have fail or we can have pass, like that we take it. Even in this I am going to use if condition. Based on the if condition I can do it. Now here declare s1, s2, s3 total result, and here I am going to use one conditional operator called as if condition. With the help of that I can calculate here, I can process this data. Now we need to assign data using set command. Set at the rate s1 equal to, use here some, we can even generate some random data. If you want to generate some random data also can be generated. You can have a rand function. So using rand function you can do that. Right here at the rate set at the rate s1 equal to rand, we use here function, then multiply this with 100. You can multiply with 100 this one. Set similarly at the rate s2 equal to rand, this rand we use here, this can return a float data, rand multiplied with again 100. This can pick some number that is not in our control exactly. Set at the rate s3, this equal to, again we put rand here, rand followed by 100, multiply with 100, like this we get. But before that, see what exactly rand can give us. Here go with the print statement above this, print, put here rand, this is a predefined function you can use here, multiplied with 100. So what happens with this, here see, so just execute, you get some result here. It's giving 96.3395. If you execute again, you will get different value. 10.902 you get like this. So this way we are getting some data, but this can be getting truncated here because s1, s2, s3 are integer. So the floating point part can be truncated. Suppose you want to use only, you want to ignore the floating point part, we want to take only integer. Therefore here you can use a floor function further. Floor we can use. In the floor function you can take only integral part of it. Here also we can use floor function, like that we can pick it. We use floor, then followed by here again we do this way, and here also we use floor. So using floor we are going to get only the integral part of it, integer part we are going to get. So like this here we are using s1, s2, s3, like this we are going to here get the values. After that we need to use here some if condition. Using if condition we need to test it. Here what, in each and every subject we should have greater than or equal to 40 marks. Therefore write here s1 greater than or equal to 40 followed by and operator we use. Okay, what we write here, then at the rate s2 greater than or equal to 40 followed by, once again we use here and, at the rate s3 greater than or equal to 40. So in such cases we should get the result. Here write set at the rate result equal to, here write it as pass. Else what we do? Else set result equal to fail, we put this way. This is going to be fail, we write in this manner. Okay, similarly now you can calculate total. Here write set total, this is equal to, here write symbol S1, then plus S2 symbol S2, then other thing is here S3. Like this you can calculate. We calculate in this manner. So what we do here, we are declaring local variables. They are available only within this anonymous code block. S1, S2, S3 result. So in the TSQL you need to use symbol for local variables. These are local variables, for that we need to use symbol. And global variables, they are going to be using symbol. Both symbols are required for global variables. There is no concept like global variable, but here it's called a system variable. For system variable we use symbol. So here S1, when we write, we are declaring a variable. It is available only in this code block. In this anonymous code block it is available. We declared here 5 variables. So S1, S2, S3 total are going to be integer variables. They can hold the integer values. The result is going to be containing here either a pass or fail depending on the data. And here S1, S2 and S3, I am going to get that from I am not giving them. So I am not inputting the data. It is generated automatically. It is going to be generated automatically using random function. Random function generates a random number between 0 and 1. So whatever value you get between 0 and 1, that is multiplied with 100. Therefore, you get always a value between 0 and 99. Maximum is going to be here 99 value you can get. So now let us try to execute this. But before executing, we need to print it. Here write print, write here result. Okay, put colon, then put plus here followed by result. You put like this result. Similarly print, again this is total, put like this, followed by here close, then write here total. So in the TSQL, strings you need to represent in single quotes. In single quote we need to represent the strings. In single quotes we are going to be representing strings. Now select it and execute. So when we execute this, first of all check for the syntax. Syntax is correct, then execute. Here see, conversion failed, it's giving message. This cannot be getting converted. Floor may be returning a float data. So therefore here we need to use some convert function. Using convert function you can do it. Here write convert, followed by here target type we need to set. Write it as here int. Like this we can use a convert function, we should use in this. We use here convert function, with that we are trying to convert it. So here also use again convert function, because whatever number you are getting is in the floating point. Floating point data you can't assign to integer, therefore it was failing there. Now like this you put int, here at the end you add the bracket. Here also try to use convert function, using which you can convert data. Okay, so at the end again you put a bracket like this. Now come to this, then execute this. Now this time execute, still it's saying here conversion failed when converting the varchar value to data type int. Yes, this is going to be here print total. At the rate total we have, this is not a string data, this can't be concatenated. Therefore we need to convert this into string. You need to convert it to string here. So when you convert it to string, you can get the correct result. Here write convert, like this you use, followed by varchar you put here comma, then put a total like this. So in such cases we can concatenate total plus, I was giving actually at the rate total, you cannot add them because this is a string and that was actually number. You cannot concatenate string and the number. You need to convert number into string. With the help of convert we are doing it. Now come to this once again, try to check for the say any syntax errors does it have. Now execute it. It says here result is pass, total marks are 203, saying like this. Next time when you execute, you get different result. This time it's fail. Total marks are 102. It's giving like this. It's giving it as 102. So like this, it's giving fail result. But whether it's doing correct or not, how to know? For that, we have to print the subject marks also. So what are the subjects? Here it is. We need to find out. So therefore here, let us try to print. Print. This is subject 1. I put like this, subject 1, put a colon, followed by here convert we put, then here this is varchar, and right here @s1. Okay, put that way. The next one is subject 2. Here it is subject 2, and this is here s2 we put. After that, this is here subject 3, and that is going to be S3, and this is here S3. Like this we calculate it. So now we can print even subject 1 marks, subject 2 marks, subject 3 marks. Now let us execute this. It's giving us here subject 155, subject 2 68, subject 78. Total marks are 201. Again execute. This time one of the marks is 8 marks, 74 45, result is fail. So it is giving us exactly correct result for us. In the subject 1 marks are 90, in the subject 3 marks are 99, but in the subject 2 marks are 16. Therefore it is giving actually us correct result only, fail. When in both the subjects, if the student is getting more than 40 marks in all the subjects, in such case the result is going to be fail, pass, otherwise it is going to be fail. Once again see here. This time also we are getting fail. In subject 3 only 1 mark. Okay. So here also it is going to be fail. Once again execute. We get fail only. Now here this is going to be 89, 89, 66. In every subject we are getting more than 40 marks. Result is going to be pass. So like this it's used here. So in this code block we are using, one is what? Relational operator. Other one is logical operator. When you want to write any piece of code at that time, you can use it. You will be using in that way. So this is for what purpose? This is, we have written here some anonymous code block, and we declared here local variables. S1, S2, S3 total result are here nothing but local variables. Okay, so S1 is integer, S2 is integer, S3 is integer, total is also integer, result is varchar. So using convert function, we can convert a floating point data into integer. Similarly, using same convert function, a number you can convert into varchar. You can do vice versa. If it is a string, you can convert into number. If it is a number, you can convert into string. So like that you can be performing two-way operations. So using convert, you can convert from one data type to another type of data. So like this is nothing but some anonymous code block we have written. With the help of that, we are calculating here result, and we are printing even total marks. Subject 1 marks, subject 2 marks, subject 3 marks, result we are printing. Similarly, so here we are using the relational operators and logical operators. Now suppose I want to write the query in a different manner. Therefore what I do? I copy this. Same program I am going to copy. This time I want to change the logic, I can change it. Program with, say, logical OR operator. The above one is logical AND, but this time I use logical OR operator. I paste the code here. I want to find out result in the other way. If S1 is less than 40, here then therefore I write here OR operator. S2 less than 40, or it is S3 less than 40. I write that way. S3 less than 40. So in such cases, the result must be fail here. It must be fail here. Similarly, this must be pass. So what happens in such cases? In any of the subject, if the marks are less than 40, it's going to be fail. Otherwise, that means in all the subjects, if it is greater than or equal to 40, so in such cases, it's going to be pass. Like this, we are trying to execute in a different way. This program is with the logical OR. So execute this now. It's giving us pass only again 55, 54, 49, because in every subject you have more than how many marks? 40 marks. Now this time what is happening? In the subject 144, in the other subjects 13 and 7, therefore result is going to be fail. Like this it's doing here. It's working in that way. So here we used logical OR operator as well as logical AND operator. We have written small piece of code. Like this you can write code blocks with the procedures. In the procedures you are going to be using these code blocks. Okay, so a procedure is nothing but a named code block. A function is nothing but named code block, but this does not have any name. Just for ad hoc purpose I am using. For this purpose I have written this. So this way what is happening, I have written some piece of code, that code I am trying to execute. Here I have declared variables, local variables. I have total 5 local variables, S1, S2, S3, total result. All local variables in the TSQL must be starting with @ symbol. @S1, @S2, @S3, @total, @result, like this it is. And you must use here declare. Using declare keyword we need to declare. Okay, now when you want to assign some data, you must use set. Simply you can't assign, you must use here set keyword. So using set keyword you need to write it. Set @S1 equal to, here I am picking the number using random function and actually getting some data. But whatever data I get, that is going to be in the floating point format. So that I want to convert into integer. For that I use here convert function. So using convert function I am doing. And whatever, see, whenever you multiply with rand 100, that can give you here some number, like for example it's taking some 80.725, something like that you get. So using floor you can get exactly 80. If the result is 80.425, something like that. So with the help of the floor you can get 80. But when you go with ceil function, in that case you can get 81. So this way you can use actually floor and ceiling functions. Later on we discuss more and more about that. But right now I am trying to demonstrate to you how logical OR and how logical AND I am using. Then followed by here I am assigning S1, S2, S3. Then I use an if condition here. So here what I write, I am comparing whether S1 is greater than or equal to 40. Then S2 is greater than or equal to 40 and S3 greater than or equal to 40. When all of them are returning, when all of them are containing a value greater than 40, so in such cases result is pass, because I am using AND there. All the combining expressions must be true to give you a true value. Otherwise that is going to be false. Here I have set @result equal to pass, else set @result equal to fail. Like this we have done. Then followed by total we calculate S1 plus S2 plus S3. With that we calculate total. Then after that we are printing everything. We print actually result, then print subject 1, subject 2, subject 3, and result also we are printing there. So like this anonymous code block is working. This is nothing but here anonymous code block. This code block is working here for us. And similarly here we use the logical OR operator. So using logical OR operator we are calculating same result in a different way. Here the logic is changed. If S1 is less than 40 or S2 is less than 40 or S3 is less than 40, in such cases result is fail. But on the top what we have written, when S1 is greater than or equal to 40 and S2 is greater than or equal to 40 and S3 is greater than or equal to 40, at that time result equal to fail we are setting, pass we are setting. But here we are setting result equal to fail whenever this condition is here returning a true value. When condition was returning true value there, result is set as pass. But here when condition is giving a true value, we are setting result as fail. So depending on the requirement, you must be using all this logic. So like that you should be writing. So today here we discussed about the various operators, arithmetic operators, then similarly relational operators, logical operators, and bitwise operators also we have discussed.